Howdy! Welcome to Aspire Mountain Academy. I'm Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video demonstrates how to use the addition rule to perform calculations. Let's get started. So here we have an example problem where we're going to demonstrate using the addition rule. And it involves the labels on bottles for a chemistry class. So the professors for the chemistry class are preparing sulfuric acid solutions for a lab assignment. And these professors were actually tested to see if they had prepared their solutions correctly. So here we have a table towards the bottom of the screen where you see the two different professors that were being tested. So Professor A had 12 correct preps and 6 incorrect preps. Professor B, wow, I hope I don't have to take a class from this guy. 3 correct preps and only 15 incorrect preps. So yeah, not the best there for Professor B. Although Professor A is not really inspiring me with confidence either. Anywho, for the classes that are taught by Professor A, what is the probability that the students received a correctly prepared solution for their lab assignment? So to calculate this, essentially we're going to take the part and divide it by the whole. Okay, so the part is the ones that are correctly prepared by Professor A. So that's the 12, and then of course the whole for Professor A is the 12 plus the 6. So we're going to take that entire row. That gives us our whole for Professor A. So the probability that he's going to prepare the solution correctly, 66.7%. Again, we're taking that whole row for Professor A to get the whole. Now, for the classes taught by Professor B, what is the probability that the students received a correctly prepared solution for their laboratory assignment? Go ahead, stop the video, do your calculations, and come back and we'll see how you did. Okay, so you should have calculated this similarly to the first question there. So the part for Professor B is going to be 3. That's the correct preps that he got, or she got. I don't know if it's a guy or a gal. And then, of course, the whole is going to be the 3 plus the 15. That's going to be 3 over 18, which comes out to 0.167. So again, we're taking that whole row to get the whole for Professor B. Now, what is the probability that any chemistry student from either professor receives a correctly prepared solution? Go ahead, stop the video, do your calculations, come back, we'll see how you did. Okay, I hope you got 41.7%. That's how this works. So we take the probability that Professor A, is going to prepare it correctly. Then we're going to add it to the probability that Professor B gets it correct. Okay, there's no double counting to consider here, so we don't have to worry about subtracting anything out. So we just take those probabilities and then we basically add them together, and that's what we get. So the probability that Professor A is going to get it right, that's going to be 12. That's his part, over the whole. This time it's any chemistry student from either professor. So we're going to add all these 4 numbers together. That's where the 36 comes from. And then we're going to do the same thing for Professor B, getting it right. So he's got 3 that he got right out of 36 total. So there's 15 over 36, which we divide out gives us 0.417. So again, we're looking at those 2 numbers under the correct preps column for our parts. Let's look now at a consumer survey. So here we've got a table that lists response rates for a consumer marketing survey, and they're categorized by age. So for each age group, you've got the number that responded and the number that refused to participate. So what is the probability that a randomly selected subject is aged 46 to 55 and responded? Go ahead and stop the video and then come back after you do your calculations and we'll see what you did. Okay, I hope you worked it this way. your sample space is the first thing you want to look for. So we're going to add up all the numbers here. That gives us 972. And then we're going to calculate the part over the whole. So the part is randomly selected from this age group, 46 to 55, and they responded. So that's this number right here, 123. There's our part over the whole, 972. That gives us 0.127. And that's our probability. Now, what is the probability that a randomly selected subject is less than 26 or more than 55? Okay, go ahead, stop the video, try this out, come back, we'll see how you did. Okay, first thing we want to do is write everything out. So we want the probability that we're either less than 26 or more than 55. Okay, this means that we're looking at the or. That's a real signal right there that you need to be using the addition rule. So we're going to take the probability of the first one, which is less than 26, plus, that's for the or, translates into a plus sign, the probability that you're more than 55, and then we're going to subtract out the instances where they're both crossing over because we want to avoid the double counting. So here we've got the probability for being under 26. So if you're under 26, okay, you're going to be in this column right here. So there's 65 and 12 in this column for the 18 to 25-year-olds. So there's our part over 972. That's the whole. That's everything added together. So there's the probability of being less than 26. The probability of being more than 55, well, more than 55 is these two columns here. So we got to add up all the numbers in those two columns. That gives us our part, again, over the same whole, 972. And there's no part here, okay? These two cells here and these 4 cells here, there's no overlapping. So we don't have to worry about this part. It just comes out to be 0. There's no double counting. That gives us the 0.127. So there's the 18 to 25. There's the over 55. And now we go to the next question. What is the probability that a randomly selected subject is over 65 or someone who responded? Again, stop the video, come back, we'll see how you did. Okay, so here's how we work this. So the probability being over 65 or someone who responded. So we're going to separate this out like we did before. Or gives us the plus sign, and then we're going to subtract out anywhere where we get some overlap. So looking at this, we're going to say that the probability of being over 65, okay, and or someone who responded. So the probability of being over 65, that's going to be this column right here. So 57 over 25, that's this column there. And then to get the probability of those who responded, that's this entire row here. So we add up all those numbers to get the part who responded. The whole, as always, 972 from what we've seen before. And then where's that 57 coming from? Well, notice we're taking this column here and this row here. So the 57 belongs in both of them. Okay? That overlapping value, you've got to subtract that out in order to avoid the double counting. And that's why here we've got the minus 57 over 972. So we punch all this out in our calculator, we get 803 over 972, which when we divide, we get 0.826. And that's the probability that a randomly selected subject is over 65 or someone who responded. So there we go. And that brings us to the end of this mini lecture. I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.